Round of applause for our next speaker, please.
Yeah, hi. So my name is Tilman Scheller. I work in the Samsung Open Source Group, and I'm here today to talk about IoT.js. So I'll just give a quick introduction, then I will explain more about the demo I've set up there, and then we can just move on to questions. So probably many of you are wondering, what is IoT.js? So essentially, if you want to describe it in one phrase, it's a lightweight version of Node.js. So what we're trying to do here is to get the success of Node.js into the embedded space. And we really, with embedded space, we are really focusing on microcontrollers which are heavily resource constrained. So we're talking about microcontrollers with, let's say, 100 kilobytes of RAM, so really low-end stuff. And one of the design goals of IoT.js is to be backwards compatible to Node.js. So we want people to be able to move easily between the two. And in terms of implementation, IoT.js really is mostly written in JavaScript. There are a couple pieces in C or C++. And the interesting question is, how do you run this on a microcontroller? And the solution to that is JavaScript. So JavaScript is a really lightweight JavaScript engine we developed from scratch. And it's really designed to be used in environments where there's very little RAM. So you can see the base footprint is at 10 kilobytes. So that can still fit on a really small microcontroller. And the other important thing to note here is that it doesn't just implement some JavaScript subset, but rather it really implements the full ECMAScript 5.1 standard. It is written in C, and currently the binary size is around 200 kilobytes if you compile it for Thumb2. The next question, or a very popular question when we start talking about this, is why do you even want to do this? So why do you want to run JavaScript on really low-end microcontrollers? And our motivation for this is that we really want, there are just so many JavaScript developers out there, web developers. We want to give them a possibility to develop for those kind of low-end connected devices in an easy way, in the way they are used to develop also for the web. And the other thing is, if you're targeting a really low-end microprocessor, then performance is usually not your main concern. It still matters, but it's certainly, there's room for a JavaScript engine there, and you can, to a certain extent, you can live with the overhead you get from using a JavaScript virtual machine. And yeah, another side effect is that hopefully you can develop software faster in JavaScript because it's higher level language than, let's say, C, for example. So all of this is open source. So both the IoT.js and JavaScript project have been released last year. They are actively being developed on GitHub, and we are feature complete. We implement the full ECMAScript 5.1 standard. We passed the entire Test 262 performance test suite, so that's really all there. And right now we are trying to build up a community around it, get people to use it, report bugs, give us feedback. So that's kind of where we are right now. And if you want to get more information about both projects, please have a look at javascript.net or it.js.net. We have lots of more stuff there. And just to give you an impression on the memory consumption, I have a slide here where we are running the SunSpider benchmark, and unfortunately you can't see it here, but so the blue represents JavaScript, and red is duct tape. So for those of you who haven't heard about duct tape is another open source JavaScript engine which aims for a really low footprint. They are not focusing on the really heavily resource constraints environments we are doing. It's a little bit more a higher segment, but as you can see, even the duct tape numbers are very low. But yeah, JavaScript still outperforms that by a significant margin. And you can see even for some of the benchmarks, JavaScript just needs 36 kilobytes of RAM. So it certainly does what it should do. So with that, I'll move on to the demo. So we have made a re-implementation of the classic Pong game, and to make it a little bit more interesting, this is not just running on a single device. This is actually running on two devices, and we have a single screen, but each of the devices controls one half of it. So the ball essentially is passing between the two devices, and we have network connectivity here to do that. So I'll just show you the diagram. Yeah. Yes, you can still see it. So essentially we implemented a simple client-server system for Pong, and we are running the client on the Raspberry Pi. There you can also see that there's a USB keypad connected to control it, and the computer opponent runs on a microcontroller, and all of it is implemented in JavaScript. So both devices are running JavaScript code, no JS modules, and but you can see the underlying stack running the JavaScript code is quite different. So on the Raspberry Pi we have quite a lot of resources. There's 1 GB of RAM, 8 GB of flash, so we can just use the traditional Linux V8 Node.js stack. But on the STM board we are much more limited. So the STM board hosts a Cortex-M4 ARM microcontroller, and we just have 192 kilobytes of RAM. So we are much more constrained here. We have 1 megabyte of flash, and the stack there is basically JavaScript, and then on top of that IoT.js, and all of that is hosted on NutX, which is an open source real-time operating system, and in this demo essentially it provides us the networking stack for the communication. And all of that, this entire stack fits within the 1 megabyte of flash, and yeah, I can show you how so it actually works. If I move the pedal, so you can see it's really. I hope. Can you see this from the back? So yeah, it's quite smooth actually, and sending a lot of packets back and forth. So I think that's pretty much it. Yeah, any questions? I think we have plenty of time for questions.
Take the microphone and move to the person who is asking the question.
You talked about the memory of the JavaScript.
Yeah.
Not about the actual consumption of the application.
Yeah. So obviously, it depends on what code you are running. So certainly, the size of the JavaScript code you're executing also matters. And yeah, but I think this demo is around on the server is around 100 lines of JavaScript code, and that still fits. So I mean, certainly 50,000 lines won't make it.
How often does the garbage collector run?
And the garbage collector is just a very simple reference counting. No, actually market sweep garbage collector. So it's a fairly straightforward implementation. And it's triggered by certain events. I don't actually know for sure. Yeah.
Thank you for your nice talk.
Sure.
So IoT has problem with security is the main security. Security is the main concern. So how can you manage it? Do you plan to add some hardened feature in your stack? Do you plan something to manage security?
So we on the JavaScript IoT.js side, we don't have any. We basically don't put any effort on security. So that's something which needs to be provided by another layer. So we are not. That's not our focus, basically.
Yeah, one question.
Yeah, sure.
How low can you go on the RAM side on the STM32? So, for example, could you take a Cortex M0 with I don't know 32 kilobytes of RAM and would it work? Or have you tested how low you can go?
Yep. So basically, the base footprint of the engine right now, if you support the full ECMAScript 5.1, is around 10 kilobytes. So that certainly would still fit. Obviously, I think you would probably get into the 32 limit quite fast, as when a program gets a little bit bigger than a couple of lines. But that's kind of the lower boundary. But JavaScript itself also has a even more compact mode where not all the features of the JavaScript language are supported, and there I think the base footprint is around 3 kilobytes. So that's kind of the lower bound.
I have a question which is kind of related to the one for garbage collection, which is how much of a performance hit do you have for you have very little memory, so I assume the performance is less good than.
Yes. Yeah, so I can also say something about that. Obviously, performance is, in a way, we are also trading space against time. So performance is certainly lower than what you get with V8 or a really sophisticated JIT. We only have an interpreter, so there's just not enough space to do any JIT compilation. And so probably you want to know how much slower it is compared to, let's say, V8, but I would say a ballpark figure is something like 100x or something. I mean, you certainly pay the price for that.
There's another one there.
Another one, yes.
Hi. I was just wondering, are there any plans to migrate this to ECMAScript 6 at some point to support ECMAScript 6? Because I hope that more people will start using it, and it would be awesome.
Yeah, so we have been discussing that and also been looking into the difficulty of implementing those features. That's certainly something which is on our roadmap to do. But right now we are not. We are first. Our primary focus right now is to optimize the engine further, and we still want to get a little bit better on performance before we start moving on to a new JavaScript standard. Do you have another one?
Yeah, no one else has got one. So, it occurred to me that, a lot of the time, unlike a browser, a lot of the time, you're going to write your code once for these kind of devices, right? As you do for these kind of controllers. So have you thought about just compiling it offline?
So that's certainly an alternative that you do ahead of time compilation. In this project we haven't thought about that. I know that other people in Samsung, if you attended the Euro LVM conference, there was a presentation about static compilation of JavaScript with LVM. Certainly that's another approach, but the catch here is that you still, in order to fully support all of JavaScript, you will always need to have a fallback interpreter, unless you restrict the constructs allowed in the language. So, yeah, I think it's not really a 100% solution for if you really want to be flexible and allow all of ECMAScript 5.1.
Oh, I can ask this way. What's your plan about the hardware
It's just for the internet audience.
What's the plan about the hardware support?
Yeah, so, I didn't mention anything about that. So, JavaScript itself is very portable. It has pretty much no dependencies. It has its own really small libc for all the basic stuff. So you can run it on bare metal just fine. We have run it on on ARM, obviously. We have run it also on the, I don't remember the exact name, but in the previous presentation, the Extensa platform, we have been running it there. So it was really easy to get that running. So basically you just recompile with a proper tool chain for that architecture and it just worked. So it's really portable and getting it to different devices should be really easy. Yeah.
I have a question.
Yeah.
So is JavaScript open source?
Yes, yes.
And do you accept this on GitHub or somewhere?
Yes, both projects are on GitHub, and both projects are on GitHub and fully open. So it's Apache license, and we are looking for contributions.
Do you accept pull requests?
Yes, definitely.
Okay. And how fast do you merge them?
That depends on the patches. Yeah. Yep.
Is the code mentioned about the ESP8266? It's also published on GitHub.
I think there's a branch right now in the repository. I think it hasn't been merged upstream yet, but it's definitely available as far as I know. Yeah.
Cool.
Yeah. Okay. Yeah.
You mentioned backward compatibility with Node.js. What does that mean exactly? And do you support the full standard library that Node.js has, as well as maybe NPM packages?
Yeah, that's a good question. So basically, what we mean with backward compatibility, that if you develop something which runs on IFE.js, it will most likely also run on Node.js. Not necessarily the other way around, because so we have a small set of modules are implemented natively, but certainly and technically it should be fairly straightforward to port them over from Node.js. But you might run into restrictions like memory size, or so we try. It's kind of a best effort thing. We try to be as compatible within the limits we have.
Okay, I do have another one.
Sure.
Sorry. What about Arduino and AVR 328? Does it run on there with a Ethernet shield or Wi-Fi shield? Yeah.
So we haven't tried that yet. But in theory, I mean, if you say AVR, so that's the I know there's AVR 32 or really the 8-bit architecture.
Yeah, 8-bit.
Yeah, I think the 8-bit architecture that will be quite difficult because of the address space. So I don't think that we will be able to get it run on that. Yeah. That's just too constrained, basically. Yeah. Okay. Any other questions? Yeah.
I like making you walk.
Yeah.
So how do you program? Let's say you have IoT.js or JavaScript running on a device.
Yeah.
How do you program your JavaScript?
So basically, we just write the code as in an editor, and then we essentially flash everything on the device,
Okay.
and then so.
So do you have the intention of being able to send code to the device while it's running, as we do with the web browser? So you can have like machines that you throw code at?
Yeah, and that's certainly something which is very interesting. As we haven't started working in that direction, but that's definitely something I think we would want to have in the future. We're also looking into the debug interface to enable live debugging on the device and things like that. So that's still work in progress. Any other questions?
No, I do have one.
Another one. Okay.
So can you run it on a Linux PC without the V8 stack and can you actually have the embedded code running on your standard Linux PC, the same code on your machine without using Node.js and V8 and all of that?
Yeah. Yes, so that works fine. You can also run JavaScript IoT.js under traditional Linux system on the desktop. That works just fine. We do all of that also for testing, and it definitely also scales up in that segment. Yeah. All right, another one.
So, have you thought about any extensions to JavaScript so you can more get to native access to games and something?
Can you speak up for the benefit of people in the room, please?
Have you thought about any extensions to JavaScript to allow you more direct access to the machine? So you can get access and direct access.
Yeah. So basically, we already, even in this demo, we have a specific module which allows us to access the. So the LED matrices, they are driven by I2C. So we are controlling that through GPIO. So we are exposing that already to the JavaScript code. So we created a kind of native module for that, and then we just use it from JavaScript. So that works today already. Yeah. And the second question, I think, was we plan to extend the language itself. So we don't have any plans in that direction. Yeah, we are mostly focusing on really just implementing what the standard requires, and that's all there. Yeah.
Okay, another question. Do you have any plans of working together to standardize the APIs used there? Like accessing JPIOs, you're not the only ones who try to do this, and it would be awesome if it's like a standardized way to do this.
Yeah. So far we haven't made any proposals in that direction. I'm also not sure if we plan to do that, to be honest. So we mostly care about creating the platform, and then we want the users to. Also, we really looking forward to any feedback on what kind of modules people need. So for us, it's kind of hard. We are developing the technology, and we still don't really know what the users want, and we are looking very much for feedback for any people working in that space and the requirements they have and so on. So that's yeah. All right. Any further questions?
Okay, I think we've got to do it. Tillman, thank you very much. We have a 10-minute